Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 16, Graphing from the Vertex Form. The learning goal today is to graph equations in vertex form. We have two learning targets. At the end of the lesson, we will come back and review these to ensure that you've learned everything you needed to from this lesson. Learning target number 1 says I can graph a quadratic function given in vertex form showing a maximum or minimum and the Y-intercept. Learning target number 2 says I know how to find a maximum or a minimum of a quadratic function given the vertex form without first graphing it. Our glossary term for this lesson is vertex form of a quadratic expression. The vertex form of a quadratic expression in x is a times x minus h squared plus k, where a, h, and k are constants and a is not 0. Now we can begin the practice problems for Lesson 16. Our first practice problem asks, which equation can be represented by a graph with a vertex at the point 1, 3? So, we need to remember that vertex form looks like a times x minus h squared plus k. And we need to remember that our vertex has h as the x-coordinate and k as the y-coordinate. So if I were to take this format, I would rewrite it as a times x minus, in this case, h is going to be 1. So I'm going to put 1 squared plus k. And in this case, k is going to be 3. Now the a, if we had a number, we could put it here, but since we don't, it's understood to be 1, and we don't need to write the 1, because anything times 1 is just 1. So now we look over here at our choices, and here we have the x minus 1 squared plus 3 on choice A. So that means A is our correct choice. Now if we look at the other ones, we can see why they're wrong. If I have x plus 1, then that is the same as x minus negative 1. And then k is plus 3, so that's positive 3. So this would actually be the vertex form for a point at -1, 3, not 1, 3. Now if we look at choice C, in this case, the h is 3 and the k is +1. So this vertex is actually at the point 3, 1, not 1, 3. And then our choice D here, because it's x plus 3, that means h would need to be -3, and then k would be 1. So this vertex would actually be at the point -3, 1. If you have any questions about how to find the vertex form when you know the vertex point, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2. Number 1 asks us, where is the vertex of the graph that represents y equals x minus 2 squared minus 8? So remember, we have x minus h squared plus k. So this means we're looking for h and k. And in this case, h is going to be 2, and k is going to be -8. So we know that the vertex is at +2, -8. So I can go over to +2, down to -8, and I can plot my vertex. Number 2 asks us, where is the y-intercept, and explain how you know. Well, if I am anywhere on this y-axis, then that means my x value must be 0. So we're going to substitute 0 for x. This would give us y equals 0 minus 2 squared minus 8. 0 minus 2 is -2. -2 squared is 4. And 4 minus 8 is -4. Which means the y-intercept is going to be at the point 0, -4. So I can come over here on my graph, and I can go down to -4, and I can plot my y-intercept. Number 3 wants us to identify one other point on the graph of the equation and explain or show how we know. So for number 3, we are going to use symmetry. Because a parabola is symmetric. Now, because I know that it is symmetric, if the y-intercept is up to, or that should be up 4, up 4, left 2 from the vertex, there must be a point up 4, right 2 from the vertex. So if we look at our graph, my red point down here at 2, -8 is my vertex. This time, instead of going up 4, left 2, I'm going to go up 4, right 2. And I can plot this other point. And that point is going to be at 4, -4. And number 4 wants us to sketch a graph that represents the equation. You need at least 3 points to graph a parabola. We have in red the vertex. We have in blue the y-intercept. And we have in orange a symmetrical point to the y-intercept. So now all I have to do is connect these points and continue my line up with an arrow in each direction, showing that this parabola keeps going. If you have any questions about how to find the vertex from the vertex form, how to find the y-intercept from the vertex form, or how to use symmetry to find additional points so that you can sketch the graph of the parabola, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3 says the function v is defined by v of x equals 1/2 times the quantity x plus 5 squared minus 7. Without graphing, determine if the vertex of the graph representing v shows the minimum or maximum value of the function. Explain how you know. So remember that vertex form looks like a times the quantity of x minus h squared plus k. Now the h and k are what give us the vertex. So in this case, the vertex is going to be -5 and -7. But that just tells us where the maximum or the minimum is. It doesn't tell us whether it is a maximum or whether it is a minimum. What tells us that is the A term. The A term in this case is 1/2. Because this is positive, it tells us that it is opening upward. So that means the vertex at -5, -7 is the minimum, and then the parabola opens upward. If the A term had been negative, then it would have opened downward and the vertex would have been a maximum. So it's the A term you want to look at when what you're trying to determine is whether your vertex is a minimum or a maximum. If you have any questions about this, please leave a comment below and I'll get back to you with any clarification that I can offer. Practice problem number 4 is our last problem in this lesson. They've given us a graph in the upper right, and they want us to match each of the 4 different lines with the equation that represents it. So here's one of those times where you want to make sure you're looking at your answer choices. Because if you do, what I want to make sure that you notice is that the x minus h plus k portion here is exactly the same on all 4 options. Every one of them is x minus 6 squared minus 5. So nothing here is going to change. All 4 of these have the exact same vertex. What is changing is your A term. So when we talk about the A term, remember, if it's positive, then it opens up. If it's negative, then it opens down. And the number tells how fast it's growing. With 1 being normal. So, as we look through our answer choices, we can see that number 1 and number 4 are both opening down. And that is because their A term is negative. If we look at 2 and 3, their A terms are 1 and 6. So since they're positive, these 2 are opening up. So right now, I know that A and C are going to have to match 2 and 3, and I know that B and D are going to have to match 1 and 4. Now I just have to figure out which one is which. So as I look at 1 and 4, I can see that 1 is opening twice as fast, or growing twice as fast. And 4 is growing 1/3 as fast. All right. Faster growth results in a skinnier parabola. Slower growth results in a wider parabola. So, number 1 is opening down, and it's twice as fast, so that has to be B because it's the skinnier one that's opening down. So number 1 matches graph B. That means number 4, which is opening down but only 1/3 as fast, because it is opening and growing slower, it is going to be wider, which is graph D. Now we have to decide between number 2 and 3, which are both opening up. Number 2 has an A term of 1, so this is normal speed. But number 3 has an A term of 6, so it is growing 6 times as fast. That means number 3 is the skinnier one, and we can see that the skinnier one is graph C. So C matches number 3. And then number 2 is opening upward at the normal speed, and that is what we see on graph A. So A matches number 2. If you have any questions about how to use the A term of the vertex form in order to match corresponding graphs, please leave a comment below and I'll get back to you with any help that I can offer. Now, before we end this lesson, let's go back and look at the learning targets and make sure you understand everything you need to be prepared as we move forward. As we go back and look at these learning targets, number 1 says that you can graph a quadratic function given in vertex form showing a maximum or minimum and the y-intercept. So remember, Your vertex form is A times the quantity x minus h squared plus k. The h is the x-coordinate of the vertex, and the k is the y-coordinate of the vertex. Once you have those, you can plot your vertex. Then, because a y-intercept always has an x value of 0, you can substitute 0 in for x and solve for y to find your y-intercept. Once you have it, you can plot that. And then using your understanding that parabolas are symmetrical, you can use your vertex and your y-intercept to find a symmetrical point to your y-intercept. Once you have those 3 points, you can draw your parabola that connects them. Learning target number 2 said you know how to find a maximum or a minimum of a quadratic function given in vertex form without first graphing it. And that simply means you know how to find the vertex. Your vertex form is again A times the quantity x minus h squared plus k, and the h is the x-coordinate of your vertex, and the k is the y-coordinate of your vertex. Once you find that point, you can plot it, and you'll know based off of your a, if your a is positive, then your parabola is opening upward, and your vertex is a minimum. If your a term is negative, then your parabola is opening downward from there, and your vertex is a maximum. If you have any questions, please leave a comment below, and I'll get back to you with any help that I can offer. On your screen, you should see a video that YouTube believes you'll find helpful. I would ask you to please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.